My name is Alan Lunningham, and I'm doing my report over DC motors. Here you can see a basic DC motor. You can see that it's got a brush on each side of the shaft. It's also got magnets on each side of it. A DC motor is an electric motor that uses a magnetic field and electricity to make torque, causing the motor to turn. The motor uses two magnets with opposite polarity along with an electric coil. This is what causes the forces that make it turn. This produces electricity and starts the motion. At least one electromagnet is required so that the current flow switches as the motor is turning. The coils are supplied with an electrical current within the motor, causing a magnetic force. To make the motor turn, the wheel must be negatively charged on the side with negative permanent magnet and positively charged on the side with a permanent positive magnet. Because like charges repel and opposite charges attract, the wheel will turn so that its negative side rolls around to the right where the positive permanent magnet is, and the wheel's positive side will roll to the left where the negative permanent magnet is. Once the wheel reaches the spot with the largest attraction, the current will be flipped, causing a change in polarity. Here are a few different applications that DC motors are used for. You have series motors, shunt motors, and compound motors. I've listed a few examples of each underneath them. Okay, modeling a DC motor, on the left side is the electrical side of it, and on the right side is where all the mechanical stuff happens at. Here's my design and parameters. The percent overshoot I set less than 5%. The settling time I put as 0.4 seconds, and it's going to have a 0 steady state error. I set L to equal 1 Henry, R to equal 2 ohms, and C was 17.591 microfarad. Here is a picture of my open loop response. This is my root locus. As you can see, its poles are negative 9.93 and negative 2. And in conclusion, the design boundaries were met, and I think the DC that was created would prove useful in many different applications.